Public spaces provide a destination for individuals, a space of recreation and interaction. However, in the 21st century, these spaces are witnessing less collaboration and activity sharing. Digitalization is connecting people in the virtual world or cyberspace. The resulting virtual platforms are acting as tools for communication, sharing moments and experiences. Minimal interaction is occurring in public spaces that are used simply as circulation nodes within growing cities. Segregation and digitalization are creating exclusive spaces, hence, inclusive design emerges as a necessity by adopting inclusive strategies targeting the two realms: digital, using cyber-physical systems, anticipatory design and digitalization, and the physical realm is by employing kinetic systems. Metropolitan cities around the world are regions consisting of a densely populated urban core with an ongoing growth rate, making them proper candidates for the intervention. London was chosen as the area of investigation due to its diverse demographic and easy access to resources. An algorithm was built to filter out potential sites in London based on several criteria, which are area, distance in between for potential networks, proximity to main roads, and accessibility. 5 candidate sites were highlighted, and after further analysis regarding 24 hours access, Elephant and Castle was chosen as the site of intervention. Documented footages of the site shows how the space acts as a circulation node and have minimal activities. An advantage of the site is its diverse surrounding, which provides a big variety of users. Public spaces are divided into slots of 3 by 3 meters, and activities are assigned through a data-driven generative system that distributes the functions along the grid. Sequentially, the physical infrastructure is informed by the system's anticipation. The system caters to a wide variety of activities organized in categories: commercial, work-related, social, cultural, and recreational, and these categories are associated to versatile typologies.
A multi-stable kinetic structure is proposed which can be compacted and moved robotically to minimize any permanent intervention to the public space. Each module is designed to fit within a cube of 3 meters. The module is divided into 4 parts, namely the canopy, column, partition, and base. At the canopy level, to ensure compactness towards the center of the cube, origami folding patterns are applied and simulated on the intended morphology. Based on the behavior of the pattern and size of the compact state, the flasher pattern is selected. Subsequently, various scales of the selected pattern are simulated on controlling its rigid and fixed parameters to determine the subdivisions of the surface to optimize for the number of panels versus the size of the folded canopy. At the column scale, its size and profile is determined such that it fits within the central void of the canopy. Origami experiments are carried out digitally to determine the pattern and scale of the column to ensure compactness. The partition is designed using the subdivision scale obtained from the canopy experiments. They adopt an accordion folding pattern to fold along the external edge of the canopy. The base is designed to functionally act as a seat, also providing counterweight to the cantilevering canopy. In the compact version of the module, the base unfolds to enclose all other parts. To actuate each of the parts from its compact to folded state, the actuation mechanism proposes a combination of air pockets situated between the folds along with tension cables attached between the panels.
The dimension of the pneumatic actuators is determined by identifying its fixed and variable parameters and conducting physical experiments to determine the angle achieved between panels. Based on the selected dimension, the number of pneumatic actuators per fold is derived parametrically based on the angle to be achieved. Each subdivision of the module is made up of solid lightweight wood or carbon fiber panels inserted between 2 layers of EPDM film. The pockets are also fabricated using EPDM. A single pump situated at the base is used to inflate the pockets. Each pocket is connected to an air splitter valve over which a servo motor and microcontroller is used to control and regulate the flow of air. Based on the part actuated, the module caters to different functions. The functions are associated with seating, canopy for shade, partition for visual blockage, and enclosure for privacy.
The anticipatory system is designed around synchronous data collection and processing. The generative system proposes an anticipatory suggestion which can be modified and actuated by the user's agency. Two data sources provide the appropriate data for the system's actuation, automating observation through computer vision. The movement and the behavioral patterns of the pedestrians are mapped. Crowdsourcing through mobile devices provide insight with regards to user preferences, interactions, and engagement to the activities taking place in the public space. Raw data are processed into numerical inputs through a number of statistical and computational processes for the system's anticipatory suggestion and provide means of evaluation for a public space's inclusivity. On intervals of 1 hour, the system suggests activity distributions based on the current site state, the data-informed inclusive strategies, and the time adaptation. According to the derived metrics, the appropriate inclusive strategies are selected and applied. Through a series of experiments, the effect of diverse strategies were explored based on predefined scenarios. Further experiments were conducted to determine the independent values of the anticipatory system's backend. Additional inclusive strategies can be implemented in the form of predefined and adaptive scenarios that correspond to different time scales of the context. Aside from time adaptation, the system adapts the assigned typologies to the activities based on climatic data of a given location. As a case study, the context and the spatial information of Elephant and Castle were captured and created digitally in a point cloud format. The anticipatory system is implemented in a digital twin format. The digital twin acts as a digital replica of the public space, reflecting its current state and allowing for the integration of the anticipatory cycle. In this particular case, a digital twin of the Elephant and Castle roundabout was generated along with its respective activity slots. The current state of the site is reflected alongside the inclusivity evaluation. The adaptation according to the time and the climatic variables derived by the API can also be inspected.
The system's interaction is effectuated through an augmented reality application. Users can visualize, modify, interact, and customize their experience in the public space. The augmented reality application was further tested on site to evaluate its usability. It allows people to assign different activities based on their will, as well as interact and connect with other users through digital means. Through CYPHY prolepsis, we envision a system that incites and enhances the social aspect of public spaces. By adopting a data-driven design approach, reactive and interactive attributes of the physical and digital realms can be integrated and achieved. Expanding on the potentiality of cyber-physical systems, the project is tightly linked with opportunities regarding the inclusion of subsequent public spaces in various urban environments. Hence, we inquire and speculate on the possibilities that this system entails in involving broader demographics and further mitigating segregation between physical and digital media. Through the project, we hope to incite a thought and further a conversation, firstly towards continual addition of digitalization to the built environment around us and how the use, implementation, and integration of the digital world with the physical can help break from the static nature of the space we inhabit.